Hi everyone, my name is Molly and I'm a computer scientist at NSWC Dahlgren Division. At NSWC DD, we pride ourselves on technical excellence. We are product focused and mission driven. With a degree in computer science, I mainly work in the field of software engineering, which means I get to design and develop software for a wide range of systems, including training simulators, machine learning and artificial intelligence applications, and, of course, robotics platforms. Today, we're diving into an exciting project where we'll create an unpowered robotic arm using nothing but common household items. But before we delve into the nuts and bolts of our build, let's explore the world of robotics and how robotics are utilized in our world. Within the last several decades, robots have evolved dramatically, and they can be found in almost every industry. The medical industry has robotic systems to assist doctors in surgeries. Space programs have exploratory robots to research areas difficult for humans to reach, like the Mars rovers. And even some of our households have robotic vacuums sweeping up floors all hours of the day. One of the most common types of robots is the industrial robotic arm, used in manufacturing and production environments for repetitive, precise, and sometimes dangerous tasking. These robotic arms usually consist of several components, with the major ones being the manipulator, the main body of the robotic arm, which includes the arm and the joints; the end effector, the tool that is attached to the end of the arm to perform an action, often a gripper or claw; the actuator, the component responsible for movement, commonly a motor; and of course, the control system, the brain of the robotic arm, which includes the microcontroller and a number of sensors. For this challenge, you'll get to design your own robotic arm. Although the design starts out fairly basic, with some creativity and imagination, there are countless ways to make this more complex and functional. Let's get started. All right, so when you open up your box, you should have several common household items. We have some straws. There should be some string or yarn, some modeling clay. Then there should be some paper clips in there, some rubber bands. There should be a ping pong ball, a cardboard tube, and a plastic needle. Also, we recommend that you have a pair of scissors and some tweezers nearby. And just keep in mind that if you are going to use any sharp objects or pointed tips, that you have parent supervision. The first thing we are going to do is create the arms. Cut a small triangular notch in a straw about halfway along its length. The straw will be a finger and the notch will be a joint. Use a needle to poke a hole just above the notch and thread some string through the straw. It may help to use tweezers to pull the needle through the straw. Tie off the string above the hole in the straw. When tying your knot, make sure that it's big enough so it doesn't pull through the straw, like that. If you're having trouble with the knot, you can reinforce the knot with something like tape. Tie a paper clip to the other end. Hold the base of the straw with one hand and the paper clip with your other hand. When you pull on the paper clip, the straw should bend. Build a second finger just like the first one. Now, you can use different paper clips for this. However, if you want to be a little bit more efficient, you can actually just use the one paper clip to control both fingers. Now that you have two fingers, form a palm for your hand around the base of both straws with modeling clay. Make sure the notches in the straws face toward each other. Go ahead and drop the fingers that you have inside the modeling clay inside the tube. Once inside the tube, make sure your fingers are appropriately placed such that they are pointing toward each other. And also, you can use your additional modeling clay to reinforce this design. When you pull your string, the draw should bend at the joints, just like a human finger. At this point, you should have a working two-pronged robotic arm. Go ahead and try to pick something up. You might notice that you're having trouble picking up the ping pong ball. Well, we can do things like attach rubber bands to the straw to make it a little bit more reinforced. Now that it's a little bit reinforced, make sure the fingers are positioned appropriately and try it again. Just like that, little improvements can reinforce the design and make it much better. Now you can try other objects. What can you do with your current robotic arm to make it pick up objects of different sizes and shapes? Now that you have a basic robotic arm, I challenge you to bring out your inner engineer and find other ways to enhance and improve this contraption. Can you make it lift heavier objects? Can you find a way for it to operate on its own? With that, I will let you get to work. Thank you for tuning in, good luck, and have fun.